Hello friends, this is Durga again from Hdfs. At this time, as part of CCA, Spark and Hadoop developer, I'm talking about loading data from Hdfs and storing results back to Hdfs using Spark. So far I have covered text file and sequence files in detail. In this video, I will try to cover how to read data from Hive tables using Hive context, and also I will try to cover how to read data from Json files. So let me go ahead and start demonstrating quickly. So to read the data, first you have to import the Hive context. For that, what you have to do is you have to say from Pyspark.sql import Hive context, and then you have to create a variable called Sql Context equal to sc dot Hive context of sc. So sc is Spark context. When you launch Pyspark, it will automatically create that sc variable, so you can use that directly, or you have to create sc equal to Spark context, and you can pass that as parameter to Hive context. Here it is context. You have to be very careful with the spellings. And now you are in the Hive context. Now you can say data equal to SQL context dot SQL, and then you can run the query on the Hive tables. So first make sure that before running this query, first you need to make sure two things. One, whether this table exists or not in the appropriate database. Two, whether you have copied hivesite.xml file into the Spark configuration directory. In this case, we are using 1.2.1, and there is a conf directory in this location, and in that you need to have this hivesite.xml either as a soft link to etc hive conf hivesite.xml, or you can directly copy by running cp command. You have to copy etc hive conf hivesite.xml to this location. If you don't have this, you will not be able to run the queries. So for any reason, if it fails, first thing you need to troubleshoot is whether you have hivesite.xml in the configuration directory or not. If it exists, you also need to make sure that whether it has the correct version or not. And also, to validate whether there is a table or not, you can run the hive command. Launch the Hive command line interface and show tables. By default, it gets into the default database, and there is a departments table. So if you do not prefix with any database name, it will try to look it in the default database. To get the list of other databases, you can run show databases command. There are three. One is default, retail stage, and scoop import. These are all in default. You can also do retail stage, show tables, to list the tables. There are no tables here, so we'll check the other one also, scoop import and show tables, and hit enter. There are two tables. So first let us run query against the default tables, default database. Now the collection is created, and you can say for in data dot collect print of I, and hit enter, and you can see that it has returned record as row. If you want to get a specific value, there are two ways to do that. One is to change your query to appropriate columns and then print the collection. You can see it has returned a department ID here. And other way is you can actually apply map function. You can actually do collect and then print I dot department ID, and enter. You can see only the department IDs. So you are actually converting the rows into the actual values by by applying the column names on that variable which is created as part of for loop. So this is the syntax for I in data.collect print I.department ID. If you want to print the department name, you can say print I.department name. Okay, because I have changed the query to select department ID, so it is not able to fetch the department name from when I try to print it in the for loop. Now you can see the department name. So that is how you can actually read data from tables in Hive and another Hdfs files. So Hive is nothing but Hive tables are nothing but directories in the Hdfs, and we are trying to read data that is there in Hive tables using Pyspark, which is satisfying our syllabus loading data from Hdfs. And the third approach is to use Hive context, and then you can also run this query against scoop import database by prefixing with the database name and hit enter, and then you can actually print the department. Okay, I have to use the for loop. For I in data collect print I.department name, and it is printing the department. There are more records in this, that's why you see more data in here. So that is how you can actually read from Hive. To write into Hive, you can use either save as text file or save as sequence file, and store into the directory which is pointed by Hdfs location. And also on top of that, if you want, you also can create table by running create table command, departments test as select star from departments, and you can specify the field delimiter and all those things. For that you need to have the knowledge of Hive. Once you have the complete knowledge of Hive, you can run any Hive query here, and I will be covering Hive in detail as part of the third module of our syllabus. Now I can hit enter. I think it has thrown some error. What is that error? Departments test table not found. I think the query is incorrect. It's correct only. I'm not sure why it has thrown error here, but in the end it is successful. You can see that it has created the table, and you can actually run the query in Hive, run show tables query in the Hive. Earlier it did not return department test, but now it has returned department's test, and then you can actually do select star from department's test and hit enter, and you get all the data which is in departments. So it ran, it has thrown some error, probably it could be something like warning or some, I am not 100% sure, but it worked, even though there is an exception saying table not found, etc. It could be a bug in Spark SQL also. So that's how you can actually create the table or write data back to Hdfs. You can apply any transformation and run any valid Hive query using Spark SQL. So you can, if you are familiar with Hive, you can run insert, load, or add any valid Hive query in Hive context to execute. That's how you can deal with Hive tables to load data from Hive or load data into Hive using Spark Hive context. And then as part of the last topic on loading data from Hdfs and storing results back to Hdfs using Spark, I will be covering JSON file format now. So JSON file format is similar to XML, but it does not have XML tags, and it looks like this. JSON stands for JavaScript Object Notation. Each record will have key and value of each and every column. The key will be the name of the column, and the value will be the corresponding value for that column for that record. So in this case, we have 8 records. The first record, it has 2 fields. One is department ID and second one is department name. And for both the values of the first record, we are storing it as key and value for department ID and key and value for department name. The keys being the column names itself and the values being the actual values. So this is a simple JavaScript notation. You need to make sure that one line corresponds to one JSON record, then only it will work. Otherwise, you might run into some issues. So in this case, we have 8 records from the departments table. I have hard-coded or hand-coded this JSON elements, and you can copy these things. Go to your VM, go to the command prompt, and then you can say departments.json and hit enter, and then you can actually copy paste those records and save it, come out of it, and then you can actually copy it to user Cloudera. What is the path I am using in the script? Pyspark. So I will recommend you to create mkdir -p user Cloudera Pyspark. And once you create the directory, you can say -put departments.json to user Cloudera Pyspark and hit enter. And the file will be saved into the JSON file will be saved into Hdfs, and now you can actually again import SQL context. In this case, you can just import SQL context, no need of Hive context. So first command is from Pyspark import SQL context, and I am creating SQL context object by passing SC as parameter for SQL context constructor. For this constructor, I am passing Spark context as a parameter and building SQL context, and hit enter. And then to read the JSON file, you can just say SQL context.json file and pass the location of your file. So in this case, departments JSON equal to SQL context dot JSON file. This is the parameter for the SQL context only, so you have to use this one only. And then you can use user Cloudera Pyspark departments.json and hit enter. Now it has created the collection with name departments.json. You can actually create a temp table, because departments JSON is not a Hive table and we are not using Hive context here. Instead, we are using SQL context. So in what you have to do is you have to register it as temp table. So departments JSON is the collection. Register temp table. If you want to persist, I think there is a function for that also. We will see that later, but for this session you can register as temp table and give any name. In this case, let's name it as djson and hit enter. Now it is registered as djson. Now you can say sql context dot sql select star from. You have to give this name because this is the name of the temp table, this is the name of the collection, from djson and hit enter. Actually you can do this for in. SQL context select star from djson paste dot collect print of I and hit enter. You can see the data the same way as we have seen earlier using Hive context. So this is how you can read the data from JSON in 1.2.1 by using SQL context and then JSON file on top of that. And then if you want to save as JSON, you can read the data from the collection and then apply to JSON function and then save as text file, and it will save as the JSON file. So let me do this. I am deleting this location if it already exists. Hadoop fs minus rm minus capital R and paste and hit enter. And now what I can do is so when we actually run the query, it will not return in the JSON format, it will return as row. Each record will be written as row. And now if you want to again save it back to JSON or save any RDD or output of query to JSON, you can apply to JSON like this and then save as text file. So first we are converting as JSON. JSON is typically in plain text, and then you can use the save as text file function itself, and then give the path for the directory under which the JSON files needs to be saved, and hit enter. And now it will create the JSON file under this location. You can validate by running Hadoop fs minus cat and paste the path and hit enter, and you can see the JSON data. I have to give the file name when I try to cat the output of the file. Now you can see that data is in JSON format. So we have covered reading text data using text file and writing back as text file. We have seen sequence file. We have seen how to read data from Hive by running queries using Hive context, and also we have seen how to read and write the JSON data by using the JSON based function of SQL context, and also to JSON function while writing back to Hdfs. We have covered quite a few topics in this, and also we have seen an example of new API Hadoop file also to actually deal with any Hadoop input output format files. If you want to get the list of those files, you can again go back to my YouTube channel. So you can watch these two videos about input formats and output formats, and you can use those methods while using the new API Hadoop file. To save using output format, you have to use save as new API Hadoop file. To read, you have to use new API Hadoop file. And then you can use almost all the Hadoop input and output formats that comes out of the box of Hadoop. That being said, that is it about reading and loading files in Hdfs. and we will cover other topics in the subsequent videos. If you like this video, please click on the like button. If you have any feedback, please use the comment section of the video. If you have any technical questions, please use Stack Overflow by tagging the questions with appropriate tags. For Spark, you should use Spark. For Pyspark, you should use Pyspark as well. And then if you want to be part of discussions, you can join my LinkedIn groups. There are two groups, one for Hadoop certifications, wherein we can discuss about any certification, and the other for Spark itself, wherein we can discuss anything related to Spark, and the group names prefixed with Hdfs and Hadoop certifications as well as Apache Spark. That being said, if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.